minute hands. Now we're going to look at a concept of relative velocity in the context of clocks. Why I'm talking about this concept is that it makes the solving of some questions extremely easy. Okay, so I would encourage you to pay attention to this and just trust me when I say that you just try to learn this concept, and you'll see the application of this concept when we'll be taking up the examples. Now, what do we mean by relative? The word relative means that it signifies the relationship between two things. That is why it will be relative. Then what is relative velocity? Now let us say, to begin with, that we have two people A and B. Okay, and the distance between them is some fixed number. Now this guy starts running and this guy also starts running. Now assume that they start running at exactly the same speed. So what will happen to the distance between these two? As you would know, as you would understand, that the distance of these two will remain exactly the same if the speed of both is the same. If you might have seen that if you're sitting in a car and your car is traveling at a particular speed and there's another car right side by side, and if that car is also moving at the same speed, the distance, no car will be able to go ahead because the relative velocity of the two cars is basically zero. What I mean by relative velocity is the difference in the velocities of the two objects. Now, how does this impact anything? The basically distance that increases between the two objects depends on relative velocity. So what I mean by this is, again, if let us say there are A and B, two people, and if they run at the same speed, it means that the relative velocity is zero. So the distance between them will not increase, because like you know, distance is equal to speed into time. So in this, just substitute relative speed or relative velocity, and time is the time. If this is equal to zero, whatever time it takes, the distance will be zero. So the distance increase between them will be zero. Similarly, if B is running at a faster speed and A is running at a slower speed, initially the distance between them is this. Obviously, if B is running faster and A is running slower, the distance between them is going to increase. Again, this distance will depend upon the difference in velocity or speed of B and A. So speed of B minus speed of A is the relative velocity or relative speed, and this is going to determine how much distance there will be between A and B. So this is basically the concept of relative velocity. Now let us try to apply this concept in the context of clocks. So in the context of clocks, basically there are lots of questions when we are asked that what will be the degree between the two hands of the clock. So when we're talking about degrees, it effectively means the distance, because as we talked earlier, the hands of the clocks, when they move, they're traveling the distance in degrees, right? That's what we say, that in 1 minute they travel the distance of 6 degrees per minute for the minute hand and half a degree per minute for the hour hand. This is what we learned earlier. So what is the difference in the speeds or the relative velocity? That is 6 minus half, which is 11/2 degrees per minute, or 5 1/2 degrees per minute. So relatively, the minute hand moves 11/2 degrees per minute faster than the hour hand. So for the time being, you just remember this number 11/2 degrees per minute, and you will see how this is going to be used at a later stage.